So what we're going to do today is we are going to review how to solve our equations by factoring. So in order to solve our equations by factoring, we have to remember what's called the zero product property. And the zero product property states that when I have two things that are multiplied together, A times B, and I know it equals 0, what that tells me is that one of these two things, either A or B, have to equal 0. Because obviously, if A is 0 and B is anything else, 0 times anything will equal 0. And vice versa. If A was any number and B was 0, A times 0, or any number times 0, will always equal 0. So that's essentially what we're going to be doing here when we're working with our factoring equations. We're going to be using our zero product property and trying to set that up so that it equals 0, and then we can say, well, one of the two things that are being multiplied has to equal 0. So let's say we had the problem 2d plus 6 times 3d minus 15 equals 0. So whenever we have an equation, and we know that this is an equation because as we see here, we see our equal sign. Whenever I have an equation, all right, the first thing I want to do is make sure that the one side equals 0. Well, now obviously in this case it does, so I don't have to do anything for that step. So step 1 is done for me. Well, then step 2 is to take each factor. Actually, sorry. Step 2 is to factor. Now, the good thing about this problem is if I look on the other side here, if I look at this side right here, this is already factored. Now, how do I know that this is factored? Well, the reason I know this is factored is because, as we see, we have two different things, or multiple things, being multiplied together. We have one thing times another thing. This is a factor, and this is a factor. When we are taking two things and multiplying them together, that means that those two things are factors. It's the same as if I had 3 times 4 equals 12. 3 is a factor, 4 is a factor. Two things being multiplied together. Okay? So as long as I have things being multiplied together, those are our factors. So in this case, we have two separate factors here. We have our factor 2d plus 6, and we have our factor 3d minus 15. So if it's factored for us, obviously I don't have to factor it. But then step 3 says to take each of these factors and set them both equal to 0. So I'm going to take my first factor, 2d plus 6, and I'm going to set that equal to 0. Then I'm going to take my second factor, 3d minus 15, and I'm going to set that equal to 0. And now I'm going to just solve both of my different equations here. I'm going to solve 2d plus 6 equals 0. I'm going to solve 3d minus 15 equals 0. So here I'm going to subtract 6 from both sides. So I have 2d equals negative 6. Then I'm going to divide by 2. So here I'm going to have d equals negative 3. For the other one, I'm going to add 15 to both sides. So I have 3d equals 15. Then I'm going to divide both sides by 3, and I'm going to get d equals 5. And both of these answers are both my correct answers. So when I write my answer out, I'm going to want to write it as the set of numbers. Oh, that was very bad. Try that again. As the set of numbers negative 3 and 5. Whenever we have multiple answers for something, we always want to write it out as a set, like we see here. Okay, we always want to write it out as a set. But this would be my answer. My answer would be D is either negative 3 or 5. Okay, so let's try another one here. Let's say that we have the equation c squared equals 3c. And again, we want to solve this. So the first step here is to always make the equation equal to 0. So what I need to do is I need to make this equation equal to 0. Make one of my sides have a 0 on it. Normally I like to leave the c squared alone. I don't like moving it unless it's negative. If it's negative, then I'll move the c squared. But because my c squared is positive, I'm going to look to move the 3c to the other side. So in order to move it to the other side, I want to subtract 3c from both sides. Now because c squared and 3c are not like, I can't actually subtract them, so I say c squared minus 3c. 3c minus 3c, that becomes 0, and now I have one side of my equation equaling 0. So then step 2 tells me to factor. So looking at this side right here, c squared minus 3c, this is a binomial, so I can't do grouping on it. So the only thing that I can really look to do right now is factor by GCF. So I see that this has a c, I see this has a c, so I can factor out a c. I'm going to factor out just the c because this has the smaller exponent, so I'm factoring out a c. I'm going to take each term, I'm going to divide it by c, so c squared divided by c, that becomes c, minus 3c divided by c, that becomes 3, equals 0. Now I take a look at what I have here. Right here, this is a times. This is where we are multiplying. Remember, wherever there's a parenthesis, this is right here a times. So my two factors in this case are c and c minus 3. So I'm going to take each of those factors and I'm going to set them equal to 0 and I'm going to solve. So I'm going to take c and set it equal to 0. I'm going to take c minus 3 and set it equal to 0, and then I'm going to solve both of these. Now this side here, this doesn't have to be solved. C is already equal to 0, so there's no solving that has to be done there. For the other one, I'm going to add 3 to both sides, so I get c equals 3, and now I have two separate answers, so I'm going to put them as a set. So it's going to be the set of numbers 0 and 3. So this would be my final equation here. Okay, so I've put up 3 problems here. So again, take the about 5-10 minutes, pause the video, try and do these factoring problems on your own. Remember, we're solving them. We want the equation to first equal 0. Then once it equals 0, we want to factor it. Then we're going to set each factor equal to 0 and solve. So pause the video, take 5 minutes, solve them, and then see if we can get them correct. Okay, so here are my answers. For the first one, I should be getting n is equal to the set of numbers 0 and negative 2. I just take each of these factors, the 3n, set it equal to 0. Take the n plus 2, set it equal to 0. Solve for both of them. Divide by 3. 0 divided by 3 is 0. Subtract 2 from both sides, n is equal to negative 2. So there are the two answers there. Here, I need to factor out an 8b first, so I factor out an 8b. 8b squared divided by 8b is b. 40b divided by 8b is 5. So my two factors are 8b and b minus 5. I set each of those equal to 0 and solve, and I get 0 and 5. For the third one here, I have to first add the 10x to both sides. Then I can factor out an x. And now I can set each factor equal to 0 and solve. So that's where I get the 0 and the negative 10 from there. Alright, so let's try a little bit of a word problem here. I know we haven't done one of these in a while. So let's say we have this word problem up here. Mike Trout hits a fly ball that has a projectile motion formula of h equals negative 16t squared plus 20t, where h is the height of the ball, and t is the time in seconds the ball is in the air. I'm a little bit impartial to using Mike Trout in this problem because, as you know, I was supposed to have last week, Thursday and Friday, off. I was supposed to be going to Texas for opening day to actually watch the Houston Astros play the Angels. So I got to miss my chance to see Mike Trout in action, but that's okay, I guess. I'm sure I'll have my chance to do that no matter what. But we want to know in this problem, how long will the ball be in the air before it hits the ground? So we have to kind of worry about a couple things here. The first thing we want to look at is the formula itself. So the formula here that we see, h equals negative 16t squared plus 20t, we have to understand what each of these variables mean. Well, we know that h stands for the height of the ball. Okay? So however high the ball is at any point in time. T stands for the time in seconds that the ball is in the air. Alright, so what it's asking us is to find out how long the ball will be in the air before it hits the ground. So we want to know the time. We are looking for time. How long before it hits the ground. So we have to kind of figure out, well, what does that mean when we want it to hit the ground? Well, in terms of the two variables that we have, h and t, we're looking for t, h being the height of the ball. Well, what is the height of the ball when it hits the ground? Well, obviously the height of the ball when it hits the ground is going to be 0. Whenever something hits the ground, the height is obviously going to be 0. So basically what we want to do is we want to replace our h in this problem with a 0 and solve for the t, solve for time. So by doing that, my new equation is going to be 0 equals negative 16t squared plus 20t. Well, now this is just a problem like we were working with before. We have a quadratic, we have a polynomial function here that's equal to 0. So all I need to do is factor out this side here. So I'm going to look for a GCF between negative 16 and 20. So in this case, the best GCF I think there would be 4, right? Then we look at the variables, t squared and t. I would factor out a t because it has the smaller exponent. Negative 16t squared divided by 4t, that's going to equal negative 4t. And then 20t divided by 4t, that's going to be plus 5. And obviously I can't forget the equal 0. So now that I have my problem factored out, I'm going to take each of the factors, which in this case is 4t and the negative 4t plus 5, and I'm going to set each of them equal to 0. 4t equals 0. I'm going to divide both sides by 4, and I'm just going to get t equals 0. Here, I'm going to set it equal to 0. Subtract the 5 first. So I have negative 4t equals negative 5. Divide both sides by negative 4, and I get t is equal to 5/4. So now because this is a word problem, we actually have to think of this a little bit more in real-world terms. The question asks us, how long will the ball be in the air? Well, I have two different answers here. I have 0 and 5/4. Well, if I think about t being 0, the time in the air of 0 seconds, would that make sense? Well, in this case, no. It wouldn't make any sense if the ball is going to be in the air for 0 seconds before it hits the ground. He hits a fly ball, right? So that means if you don't know anything about baseball, you've got the ball, and it goes a fly ball. You're hitting it up into the air. So a time of 0 seconds would make no sense for the ball to stay in the air for 0 seconds. So yes, t is equal to 0 in this case, or could equal 0, but it doesn't make sense for the problem, so we don't use it. But then I look over here at 5/4 and I say, well, would that make sense? If the ball's hit in the air, could it stay in the air for 5/4 of a second? Well, yeah, that makes sense. 5/4 of a second is 1.25 seconds, or 1 1/4 of a second. So yeah, that definitely makes sense. So in this case, my only answer would be that it stays in the air 1.25 seconds, or 5/4 of a second.